Hey guys, what's up everybody? Welcome back again to another video tutorial from the Apex Academy of Mathematics. My name is Akin, otherwise known as Apex Selenio, and in this video we're going to be talking about the laws of indices, or what we know as the laws of exponents. Alright, and if this is a topic that have always been giving you issues, please ensure that you watch this video to its entirety. Hit like on the video, make sure that you smash that subscribe button below and turn on your post notification bell for future tutorial videos like this one. Alright guys, so let's jump into the video and make sure that this will never be another problem that you have. Alright, great. Alright, so it starts here by saying that there are 7 laws of exponents with 3 extensions. Alright, so there are 7 standard laws. Alright, but along these laws there are extension rules that may not necessarily look like the standard law, but it basically is. It just looks a different way. So we're going to explain what this means momentarily. Alright, and I've pre-written these rules here along with some examples, some basic examples, which I'm going to be explaining to you what these are. Yes, and so let's get right into it here. But first thing I want to make sure that you understand here is that these letters that are in red right here, B and A, they are non-zero digits. Alright, so they cannot be 0. They can be 1, 2, 3, 4, all the way to infinity, or it could be -1, -2, -3, all the way to infinity, but it cannot be 0. Okay, and M and N are any integers, and we have already discussed this in a previous video, which definitely I would love you to check out. I will post the link in the description below, and you can definitely see that video. That should help you out a lot with what integers are. Right, but M and N are any integers which may be positive or negative whole numbers. All right, good. So let's look at law number 1 right here. All right, so this law here is called the zero property of exponent. The zero property of exponent. All right, and please be reminded that these laws are not written in any particular order. There are some teachers and instructors, tutors who teach these in particular order, but when you're using them, you don't need to state that, hey, I'm using law number 1 or law number 4 or law number 5. You just need to state what law you're using to solve what question. Alright, so I've written my laws not necessarily in the original or the most renowned order. However, this is how I go about setting these up for you. Alright, so let's look at the first one, which is called the zero property of exponent. And this is simply saying here that if I have a base, these numbers here, this B right here, is called a base. Alright, so if I have a base number, of course it cannot be 0, and I raise it to a 0 power or a 0 exponent, yes, or a 0 index, then my end result will always be 1. It's as simple as that. Anywhere you see a number except 0 that's raised to a 0 power, then the result is going to be 1. So here, for example, I have a to the power of 0 is equal to 1. A to the power of 0 is equal to 1. And of course, I have a numerical example here where 2 to the power of 0 is equal to 1. All right. I'll have a part 2 of this video. I'm going to be doing some examples, and I may show you the proof of why this property is so very true. All right, you're going to use another law. All right, you're going to use the quotient property of exponent to prove this law. All right, so we can take a look at that in part 2. Here now we are going to move on to the second indices law. Here it says the negative property of exponent, and this is simply saying here that if I have a base number, here we have a base number B, it could be any number except it cannot be 0, of course, right? We have a base number here, and it has some sort of negative index or negative exponent or negative power, whatever you want to refer to this little n as being here. It has a base number raised to a negative power, right? Basically, what we do here is that we reciprocate the quantity that's right here, and we change the power from negative to a positive. Because what you've got to understand here is that this b right here is actually over 1. It's a fraction. It's a whole number, but a whole number with an understood denominator of 1. So when I say reciprocate, I'm turning the 1, putting the 1 above and the b below. That's why we have this 1 that appears here, because it's already understood right here as being b over 1. So reciprocating it becomes 1 over b, and we change the power from negative to positive. All right, now there are instances where it might be reversed, yes, where you might see 1 divided by the base raised to the negative power. Simply you do the same principle, reciprocate. Yes, reciprocate it. So we're going to turn this upside down. So this is going to go back to being b over 1. All right, and then we're going to change the power from negative to being positive right here. All right, fantastic. So hopefully that was clear for you. Here I've given you another way how it can be written. All right, so this is saying the same thing here. A to the negative n is equal to 1 over a to the n. And here's an example. We have 2 to the negative 5. So this 2 here is over 1, right? So we just turn it upside down, and we basically get 1 over, and we change negative 5 to positive 5. All right, so hopefully that was clear for you there. Okay, so let's look now at the product property of exponent, the product property of exponent. And this is perhaps one of the most used property. They're all used, but this is one of the most used property of exponents. All right, property of exponents. So here we have a base b raised to the power of m. Yes, and there are no signs between these two letters, so brackets or parentheses means multiplication. You're going to most often see it written like b to the m times b to the n. All right, but I've chosen to write it like this, for example. All right, like this. And sometimes you might see b to the m times b to the n. So this dot here means multiplication. So don't be confused when you see it in another textbook. It means the same. So brackets, multiplication sign, a dot, they both means multiplication here. All right, so we have b to the m multiplied by b to the n, and that's equal to b to the m plus n. So basically what we're doing here is that we are adding the indices. We're adding the indices, and it doesn't matter if one is negative or one is positive. We can still use the product property to help us. So this will bring into your ability here for you to add integers. All right, so we're going to be looking at some examples in part 2 of this video. All right, or I should say part 3, because I'm going to make this video is going to be a little bit too long if I'm to go through all these properties, including the ones here that are on page 2. All right, so I'm gonna have to definitely cut this video short and pick up in part 2. All right, so you're gonna see examples in part 3. All right, good. So let's look at part 4 here. Let's just reiterate this for you. Whenever we are multiplying and the bases are the same, then we are going to add the powers or add the indices or add the exponents. All right, so hopefully you're clear with that. Here's an example here for you. 2 to the power of 5 multiplied by 2 to the power of 3. We don't need to work out what these are individually. All right, it depends on if the question says, hey, give me the exact answer, or give me the answer in index form, then you may just be needed to use this law here. So we just add the 5 and the 3 right here, and we're going to get 2 to the power of 8. So if you were to work this out and work this out and multiply them, you'll get the same result as 2 to the power of 8. All right, wonderful. All right, so this is the final example in this part 1 of this video here. Quotient property of exponent. So it says here that bases are the same. Yes, bases are the same. Bases are the same. B to the power of m divided by b to the power of n then we are going to subtract the power. So we just rewrite one of the base, or rewrite the base one time and subtract the powers. All right, and again, you be able to see it like b to the m divided by b to the n, or you may see it like this here. So we basically just subtract the powers, and here's an example: 2 to the power of 5 divided by 2 to the power of 3 is equal to 2 to the power of 5 minus 3, and we're going to get 2 to the power of 2 here. All right, wonderful. All right, guys, so that takes care of the first 4 laws of indices, or the laws of exponents. Please do watch the next video for explanation on laws 5, 6 and 7, along with the extension examples. All right, so thank you so much for watching this tutorial video, and I'll see you in part 2. Take care until then.